Hello, class. This is a week one lecture, part two, and I wanted to go over some things about the actual topic for this week, which is register instructions. And so we're going to go into module one here and take a look at a few things. You should have already reviewed the syllabus. Do the syllabus quiz, which shows that I actually showed you the syllabus and you understand it. And then we have some supplemental content that we're going to look at here. And then you should do the pre-quiz before you come to the lab. Just helps test your knowledge and shows you what things you need to focus on for this week. And then our lab for this week is register instructions. So we've already really created this lab at one point last 8 weeks with the counter program that we did, where we looped the program through 5 times or 2 times or whatever it was we set the counter to, and then it stopped. So that was a conditional looping program. And so the supplemental content, I was going to create a video that showed you exactly how to do the lab, but Joe already has done that for us. And so if you click on the supplemental content here, we have 3 videos that show exactly what to do.
In today's lesson for register instructions, we will start off by assigning a register that can be used for our programming.
Okay, so that's it. I'm not going to show you the whole, or we're not going to watch the whole video here, but please watch those 3 videos. We may look at them again in class as we work on these on this lab tonight. So let's go back to my modules. I'm just going to go back to the home page. I don't like Canvas the way that you have to navigate through it. It gets very confusing at times. So anyway, we're going to look at register instructions in just a little more detail here in just a moment. So again, to go over the assignments that are due for Module 1, you have the Module 1 quiz, syllabus acceptance quiz, and then you have the pre-quiz, and then you do have a paper assignment here, and I will show you that. I thought I had it open on my screen. Maybe I do. But we'll see here. Let me look over here. Yes. So there's an assignment where you're given some programming examples, and then you have to answer questions about that program. Given the following program, this is number 1, given the following program, identify what counter value will be at the end of the program. So you got to look at that and determine what the counter will be at the end of the program. And number 2, given the below program, describe what will happen. So you got to look at that. I think we had some test questions similar to that at some point, either on the final exam or the certification exam. I can't remember. Maybe both. And then you've got some other questions about registers here. So where do you get some of the information to answer that? Well, they have provided a PowerPoint for you here, and that's under that supplemental content thing. I'm going to see if this is recording for us here. Okay, so register instructions, arithmetic registers used to store numbers. Numbers can be used for arithmetic operations like tracking part count or cycle count, which we've already done. And you can put IO groups data in there, and then default number of registers is 200. So there's 200 registers there, they say. That's the default number. Data registers can be used for indirect addressing. This method allows one program to be able to run multiple style parts, multiple positions. In other words, if you have a robot that's loading and unloading multiple machines, say you have 6 or 8 machines sitting around the robot, and it's moving parts around between those machines. So you can assign the positions by machine number like that. And this little example here program shows you how that can be done. You can also set speed limitations in there. Robot speed. Here they've set it to 1500 millimeters a second. And if you look down here at the line of code that does that, you have a position register 10, which goes to machine number 5 if you look over here to the right. And then you call register number 11, and the value that's in there will be set at millimeters per second. And we look over here at register number 11, and we see that that's 1500. So that's what they're trying to explain here, how that can be used. So you can have set numbers in the register that you can use in different programs. And it also will allow a PLC to control the robots. So example of direct addressing of a register is just putting the number in, the set value in here. Like we said, R3 equals 8. Oh, doggone it. Go back. Keys are very sensitive. And then the indirect would be to have another value moved into that register from another register. That's what that means. So you have direct and then you have indirect. So, and you're going to be working with both examples. So this page to me is very confusing. And I'm going to go on to the next one because I think you have some questions about this, and it's probably pretty important to know you can mix plus and minus in the same instruction. Arithmetic operations within an instruction that mixes plus and minus will be performed from left to right. You cannot mix multiplying or dividing in an instruction that already contains plus or minus. You can mix multiplying and dividing in the same instruction. Arithmetic operations within that instruction that mixes multiplication and division will be performed from left to right. You cannot mix plus or minus in an instruction that already contains multiplication and division. The maximum number of arithmetic operations you can have in the same instruction is 5. Programs do not read the lines of instruction again unless instructed to do so, unless they're looped. So they'll go by it one time, and then unless they're instructed to loop back and go over that again, they won't read it again. So for example, in our cycle counter, we loop it around and subtract 1 from the content of the counter each time we loop through so that we can control the cycle. Here again is another kind of confusing slide, but it does define what each of these areas of the program code mean. So there's where you set direct or indirect, and the operator is the arithmetic or the equal to, not equal, less than, greater than, and so on and so forth. And then you have a value, you have a constant value or a value that you pull from another register, and then what you want it to do if these things all become true. The action, you can either jump to a label or you can call the program. So that slide is, at first you look at it, it's a little bit confusing, but it does really break it down for you and help you understand how this line of code works, the if instruction. So if something happens, If something lines up and all becomes true, then this will happen. We're either going to jump to a label within that program, or we're going to call another program. And so then we have the if IO instructions, and we use those for our final lab. So if we have a digital output, digital input, a robot output, a robot input, so on and so forth, then whatever we set that to do, we want it to be equal to or not equal to. And then we set a value, either something that's stored in a register or a hard on or off for a digital input, for example. And then also we could say if digital output 1 is equal to digital output 2, then we could, do something. So all these things here can be set by us. And then our action, again, would be we're either going to jump to a label that we've predetermined, or we're going to call another program. So here they give you, they give you an example down at the bottom. If digital input 1 equals on and digital input 2 equals off, jump to label 2. So this was a Boolean. This was an AND instruction. So you got to have. We've set two conditions here, and one has to be on and one has to be off. So you got, a bunch of different kind of scenarios you can set up here to control your robot. So here's a good example for looping a program, and I'll probably print this one out and give it to you so you can find out how to loop your program. So let's walk through this real quick. We set a 5 into register number 1. We physically place that number in there in our program, from our program, and then we set a 0 into register number 2. We add a label, and then we have our robot move instructions here. So we're moving to position 1, 2, 3, and 4. And then once we move the robot, then we come down here and we say, okay, register 2 equals register 2 plus 1. So, and then if register 2 is greater than or equal to R1, then jump to label 2. So if this is not true, then we jump back to label 1, which is up here, and we run through the whole thing again. So we're going to loop through here 5 times until register number 2 equals 5. And then once that happens, we go here to label 2, which ends the program. Okay, so that's pretty straightforward stuff. And just remember these instructions, because this is how we set up our counter. We have the if instruction and the jump label instructions, and we have to set these values into our registers. So not real difficult. And again, I'll have this printed out so you can use it for your lab that you're going to do tonight. And what else do we have here? Did I do another one? Okay. Okay, this one, the for do loop creates a loop that repeats a series of programs instructions for a specified number of times. And again, this one does the same thing, except instead of adding, they're only using one register, and they're subtracting the number instead of adding it. So every time this goes through all the position moves and gets down here, R1 equals R1 minus 1, it'll subtract 1. So then if R1 equals or less than 0, jump to label 2. So again, a way of doing the same thing that we did in the other program, but using less lines of code. So we used subtraction instead of addition to do that. And then the while loop creates a loop that executes until a specific condition is or is not satisfied. So if we look here, we have if D digital input 1 equals off, jump to label 2. So if digital input 1 is off, then we jump down to label 2, which will end the program. But if we leave the switch on, or whatever digital input 1 is, then the program will keep running here, because it goes down to jump to label 1 back up, until this statement in line true becomes, or in line 2 becomes true. Okay, this program will execute until digital input 1 is off, then it will end. So that's how we control the robot with a digital input. So we could actually set up and have a PLC running that would send an input to the robot. So this is one way that we can control the robot with a programmable logic controller. And so here's another example of a looping program. The repeat loop executes as long as the conditions is satisfied. So let's look at this program. We have the label 1 here at the top. We joint move to position 1, joint move 2 down through 4, and if DI10 equals on, jump to label 2. If not, we're going to keep looping around here. So another, this is an on control. So we turn an input on to stop the program. In the other example, we turn, in this example here, we turn the program off, or the switch off, to stop the program. And here we turn it on. So, you know, why? I mean, what's the reasoning here? Well, it just depends on what system you're using, what kind of inputs you have, and so on and so forth. But you have both options. And so that's all of our looping programs. And again, we get to do one this evening here. And let me look. Let's go back to our lab now. So here's our lab. And all this stuff pretty much is the same in each lab. So the objectives, but the procedures is what you're really interested in doing right now. You power it up, you create a program and name it counter. And also I always say put your name or initials after it so we know that it is your program, because we have multiple people using the same robot, and there's also some robot programs from other classes that haven't been cleared off yet, which I'm in the process of doing. So modify this program to cycle a predefined number of cycles and then end. We'll need to assign a data register, assign a register at the data screen to use for your linear speeds Increment the register within the loop. Use a conditional branching instruction to monitor the number of cycles while the program is in cycle. And then you stop the program. Okay, so that's it. We'll be working on this lab. You got any questions, email me or text me. And I'll see you all in the lab. Thanks for watching.